All right, chemistry kids, here we go. We're going to start Unit 3, which is Atoms and Periodic Table. You should have this already. This is your objectives for this unit. And if you notice next to each objective that we have the chapter and the section number, you can read more about it if you want more detail or need more repetition. All right, so let's get right into it. Let's go through the first part. First part is the beginning of the atom. So what is an atom? What are the parts of it? How does it look? So on and so forth. So here we go. First question, what is a proton? Well, a proton is a positively charged particle. Okay, positively charged particle in the nucleus. Okay, so a proton is a positively charged particle in the nucleus. A neutron is a neutral, meaning it has no charge. It's a zero, not an O. A neutral particle in the nucleus. And then an electron is a negatively charged particle in the nucleus. All right, so we have our three parts of our atoms that we're going to really concentrate on the most. Proton, neutrons, electron. Proton's positive, neutron's neutral, electron is negative. Sometimes electrons will be written like this, E negative. So don't get confused if you see either or. All right, now how it kind of works out is this. How do I find the number of protons? Well, the number of protons is equal to my atomic number. All right, so when I look on the periodic table, which you guys are going to have one of these, a periodic table, all right, right here, atomic number. It is the biggest whole number right there. For example, this one, boron, it's 5. All right, so the atomic number is the whole number in the periodic table next to the element. All right, a number of neutrons. Neutrons is going to be the mass number minus the atomic number. Okay, so mass number minus the atomic number. Here's how you find the mass number. The mass number, you look at a specific element. So let's look at the example here. We have boron, and it's 10.8. Well, we can't have 0.8, so you round up to 11. So the mass number is the rounded atomic mass. So it's 11 minus 5, so therefore my number of neutrons would be 6. 11 minus 5. Okay, so atomic mass, or mass number, minus the atomic number is your number of neutrons. And then an electron in any normal atom, right, without a charge or things like that, this is also going to be equal to your atomic number. So look at boron again here on the periodic table. Boron's atomic number is 5. That means I have 5 protons and I have 5 neutrons because an atom wants to be neutral. It wants to have the same number of positive charges as the same number of negative charges as well. All right, so it's for a normal atom. When we start talking about ions and isotopes, that's when things will get a little more complicated, but not crazy complicated. All right, so going on, once we know what these are, our protons, neutrons, electrons, now we can actually figure out what an atom kind of looks like. Well, we know the protons are in the nucleus, we know the neutrons are in the nucleus, and the electrons are not in the nucleus. Why did I write that? I don't know. Are in the cloud, okay, which is around the nucleus. All right, so it kind of looks like this. Proton, neutron, neutron, proton, for example. So here's my nucleus. All right, so we'll go nucleus there. That's my nucleus. All right, they're all kind of held together. And then flying around this nucleus are different electrons. So these are my electrons. And these are my protons. And these are my neutrons. And then these are my electrons here. I'll write that out. So how you kind of think about like what it looks like, think of like the solar system. The middle is the sun, and the sun is composed of protons and neutrons. And then around the sun is the planets, but around this nucleus is the electrons, and those are floating around the nucleus in kind of random fashion. All right, so that's our general form of what we're going to use. It's going to get more specific later on, but that's the general form. So electrons are around the nucleus, protons and neutrons are in the nucleus. All right? And how you figure out how many protons and neutrons there are? Right down here. Well, protons again is the atomic number. How many electrons is going to be equal to the atomic number in any normal atom. And then neutrons is going to be the mass number minus the atomic number. All right, so that's how you find out what's going on. Now, when elements lose or gain electrons, they become an ion. So when we lose or gain electrons, it becomes an ion. And an ion is going to be a negative or positively charged. All right. If we lose or gain neutrons, it's called an isotope, which I didn't even spell right. Way to go. Isotope. Okay, that's when you lose or gain neutrons. So that means the mass number is going to change. Whereas a proton, if you change this, well, you change the atomic number, which means you get a new element. So an atom can lose or gain electrons and keep its identity. It can lose or gain neutrons and maintain its identity. In other words, it's the same element. It can't lose or gain protons without changing what type of element it is. So it could go from like boron to helium or something like that. The guy that's responsible for creating this whole periodic table organization, he might not have got everything right, but he got the most credit for it. So the guy's, his name is Dmitri. I'll spell it better. I'm having trouble spelling. Dmitri Mendeleev. Okay? Dmitri Mendeleev is a Russian guy. We'll watch a little video on him, but he's considered the father of the periodic table. So if I was drawing an element out, let's say I was looking at my periodic table and I want to draw hydrogen. Okay, so I look at hydrogen, I see its atomic number, I see its mass number, I see its symbol. So there's a couple ways to represent this. Hydrogen goes like this. My mass number goes on top, my atomic number goes on bottom, and then if it got a charge, let's say it got a +1, that's what the charge would be. So when you see an element written in different ways like this, all right, with a symbol on it, there's different ways. You should know what each number means. The number on top is going to be your mass number. The number on the bottom here is going to be your atomic number. And this right here is going to be your charge. Okay, what's your charge? Well, the charge is how many ions, how many electrons it lost or gained. So this is going to be electrons lost or gained. All right, so if it's a positive charge, positive means lost electrons, or if it's a negative charge, that means it gained electrons. All right, so there's your brief review of just the atomic items and how to look them up. All right, we'll go into more detail in class, but I hope this helps you out. So make sure you have all these notes, and we'll see you soon.